This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Let's learn how to find the standard deviation of random variables. Think about the heights of all the buildings in a big city. Some buildings are very tall, while other buildings are short. If we pick a building at random, we could use the mean height to guess how tall it will be. This is called the expected value. Some buildings are very close to the mean height, while others are a lot shorter or a lot taller. To find out how much a typical value in the dataset differs from the expected value, we can calculate the variance. The variance is one way to measure how spread out the data values are. In this case, the variance would be high, since the heights are pretty spread apart. But the variance of the heights of houses in a suburb would be pretty low, since the heights are more uniform. Did you know there is another way to measure how spread out these values are? We can find the standard deviation, which is just the square root of the variance. This is useful because the standard deviation is measured in the same units as the dataset, whereas the variance is measured in square units. Additionally, standard deviation is a useful measure for normal distributions. If a dataset has a normal distribution, the data will form a bell curve. About 68% of the data will fall within one standard deviation of the mean. About 95% of the data will fall within two standard deviations of the mean, and about 99.7% of the data will fall within three standard deviations of the mean. Nice! Let's try calculating the standard deviation of some different datasets. The table below shows the probability distribution of a random variable x. What is the standard deviation of x? First, let's find the expected value of this dataset. We will start by multiplying each data value by its probability. 5 times 0.2 is 1, 9 times 0.5 is 4.5, and 12 times 0.3 is 3.6. The sum of these values is the expected value, 9.1. Now, let's find how much each data value deviates from the expected value by finding their difference. 5 minus 9.1 is negative 4.1. 9 minus 9.1 is negative 0.1. And 12 minus 9.1 is 2.9. A negative value indicates that the data value is lower than the expected value, while a positive value indicates that the data value is greater than the expected value. Next, we will square each of these values to find the squared deviations. Finally, we must multiply each of the squared deviations by its corresponding probability. 16.81 times 0.2 is 3.362. 0.01 times 0.5 is 0.005. And 8.41 times 0.3 is 2.523. The sum of these values gives us the variance, 5.89, which we represent with the lowercase Greek letter sigma squared. Now, to find the standard deviation, we just take the square root of the variance, or the square root of 5.89, which is approximately 2.43. Nice work! Let's try another one. Mariana kept track of how many pages of her favorite comic book series she read each day. Y is the number of pages that she read on a randomly chosen day. What is the standard deviation of y? Let's put this data in a table to help us stay organized. The first column will list the number of pages, y, and the second column will list the number of days that Mariana read that number of pages, also known as the frequency. She read 20 pages on 2 different days, 25 pages on 4 different days, 34 pages on 3 different days, and 41 pages on 1 day. Great! Now let's find the expected value. Wait a minute. Before we can calculate the expected value, we'll need to find the probability of each data value. First, we'll need to find the total number of days. 2 plus 4 plus 3 plus 1 is 10. Now we can find the probability of each data value by dividing its frequency by the total, 10. 2 divided by 10 is 0.2, 4 divided by 10 is 0.4, and so on. Next, we'll multiply each data value by its probability. 20 times 0.2 is 4, 25 times 0.4 is 10, and so on. The sum of these values is the expected value 28.3. Now, let's find how much each data value deviates from the expected value by finding their difference. 20 minus 28.3 is negative 8.3. 25 minus 28.3 is negative 3.3, and so on. Then, we'll square each of these values to find the squared deviations. Finally, we will multiply each of the squared deviations by its corresponding probability. 68.89 times 0.2 is 13.778, and so on. The sum of these values gives us the variance, 44.01. Now, to find the standard deviation, we take the square root of 44.01, which is approximately 6.63. Great work calculating the standard deviations of random variables. Keep practicing.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.